Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about exponential curves and integration. Now the question we're going through here is 2017 Paper 1 Question 6 Part A. In this question they've given us an x and a y axis, and they've drawn the curve g of x, which is e to the power of x. They've then told me that h of x is e to the power minus x, and they asked me to draw it in the domain from 0 to 1. Now you should notice that I've already worked out my coordinates here. Now most students do this fully just on their calculator, but if you're doing it on your calculator, make sure you get into the habit of actually writing out your coordinates. So I've written out my coordinates. The first one is the coordinate 0, 1, 0.2, 0.82, and so on. So you just plot your 6 different coordinates. Now obviously mine is quite rough because I don't have lines along my board, but yours obviously needs to be as accurate as possible. So all I need to do is plot my 6 coordinates and then draw my curve. Remember, it's a curve, so make sure you don't use a ruler to join up your points because it's not a straight line. Now for Part A, so Part A was relatively straightforward in this question, but really it's an intro to Part B. So let's move on now and talk about Part B of this question. Okay, so in Part B of this question, we're asked to find the area enclosed by g of x, h of x, and the line x equals 0.75. So the first thing you need to be able to do is to draw the line x equals 0.75. So this is the equation of a line. If I'm given the equation of a line and it's just x equals a number, if there's no y dimension to it, then that means that it's a vertical line. So the line x equals 0.75, just go to where your 0.75 is on your x-axis and draw a line straight up. Okay, so I'm trying to find the area enclosed by g of x, h of x, and the line x equals 0.75. Or in other words, I'm trying to find this kind of triangular looking shape in here. Now remember, obviously it's not a triangle because both g of x and h of x are curves. You need to recognize that to accurately find this area, we need to do integration. When we integrate, we're getting the area between the curve and the x-axis. So for example, let's say I got the integral of g of x. G of x is e to the x. So if I get the integral of e to the x, what I'm doing is I'm getting the area between the curve and the x-axis. So the limits that I'm going to use in this question are 0.75 and 0. So if I got the integral of e to the power of x from 0.75 to 0, that would tell me the area underneath the curve g of x from here to here. So in other words, it would tell me this whole section. I would get the area of this whole four-sided shape. Now clearly I don't want all of that, but that's the first thing that I'm going to do. So the first thing I need to do is get the integral of g of x from 0 to 0.75, which is this four-sided shape. Then what I need to do is work out a way of getting the area of this bit in here. So clearly to get the area of this bit in here, it's the area between the curve h of x and the x-axis. So if I get the integral, remember h of x is e to the power of minus x. So if I use the same limits, 0.75 to 0, if I get the integral of h of x from 0 to 0.75, that will tell me the area between the lower curve and the x-axis, so it's this section here. So if the first thing I do is get the area between the higher curve and the x-axis, then I get the area between the lower curve and the x-axis. If I just subtract my two answers, I'll be left with the bit in the middle. So all I need to do is get this and subtract this. So let me just wipe out the board and we'll do the actual maths up here. Okay, so once we've figured out what our actual integration is, we can kind of ignore our curves for the rest of it. I want to get the integral of g of x and then subtract the integral of h of x using the limits 0.75 and 0. Now you should recognize that if your limits are the same, we can write this as one line. We can just write this as one integral. So because the limits are the same, I can rewrite this as the integral of e to the x minus e to the minus x. So I can integrate them all in one go. And my limits are 0.75 and 0. So I can actually just rewrite this as this. Now, clearly you want to go to your integration page on your log tables. The integral of e to the x, well, it just stays the exact same. It's just e to the x. The integral of e to the x just stays the exact same. Then I'm going to take down my minus, and the integral of e to the minus x is e to the minus x divided by minus 1. So divided by the number in front of my x. So the integral of e to the minus x just stays the exact same, divided by the number in front of the power. So that's my integral. And because I have limits, I don't need to add in a plus c. So my limits are 0.75 and 0. Now let's just simplify our signs here. Clearly it's minus, and then there's a minus on the bottom. So the minus here and this minus multiplied by minus gives me a plus. Which means I can rewrite this line as e to the x plus e to the minus x. So my integral is actually just e to the x plus e to the minus x, and the limits are 0.75 to 0. So now all we need to do is apply our limits at the top of the board. Okay, the final bit of this question, and I actually find a lot of students make silly mistakes at the end here. So I have e to the x plus e to the minus x, and the limits are 0.75 and 0. So to apply my limits, the first thing I do is sub in my upper limit. I just rewrite what I have in my square brackets, except everywhere there's an x, I sub in 0.75. So 0.75 minus 0.75. Then I put a minus between my brackets, and I sub in the lower limit, which is 0 and 0. I just plugged all of this into my calculator. I got each of my values here. I can just use it's just calculator work from there. 0.589366, and it asked me to 4 decimal places, so I have to round up to 0.5894. So that's my final answer in this case. So again, I hope this video made sense. If there's anything you're unsure of there, as always, just make sure you let me know in class, and I'll try and explain it for you differently.